Okay. For the next 1 hour, 1 hour, 15 minutes kind of things, let us discuss on some whatever things happening today, and what are the things we all are seeing in the society, and how we, the engineers, researchers, uh, and academicians, how can we handle that, and in fact the students, how can we take it forward? Okay. The topic for today's discussion is 5G and beyond, what the society is looking for. So we'll start with a couple of use cases. Specifically, I will try to introduce you people with the use cases what we are seeing today, and what are the use cases we'll be experiencing tomorrow. Okay, the applications we'll be experiencing tomorrow, and these use cases actually will take us to the kind of research or academic thing we should focus, or kind of startups we should focus, and kind of business we should see in future. Because ultimately, the need, or the whatever need is the mother of all invention, right? So the use case of need is the main thing. Like in the COVID 2020 when it started, so everything became online, including today's lecture also. So when things are becoming online, things are needed to become online, forced to become online, right? So the communication technology has evolved. Then the device prices has gone down. Similarly, a lot of new standards have come, new regulations have come. Okay, new applications also started, like Google, Zoom, Teams. So many things started, right? So every new thing, every new use case, new requirement will bring us new ideas, new opportunity to do more research, and to focus our academic thing in that particular directions. Okay, the academia is evolving, research is evolving, and everything is being tuned by the business, and business is being tuned by the user itself, the customer or user, or the we the people, the common man, right? So we'll start with the present and future use cases, then we'll see how are we going to realize the use cases. So ultimately, the realization of use cases, like one example I gave in the pandemic, right, scenario. To realize the use case, so many things were required. Not only the 5G or 6G or 4G, whatever, but also the device, the cheap device, the cheap laptop, mobile phone, right? Affordability, then energy, right? Everybody is having so many things that will lead to some more energy crisis, that will lead to some kind of pollution also, environment hazards things also is going to happen, and that will also lead to various other diseases, like say, some depression, so many other things also will come into picture. So we'll have to see how to realize the use cases, and how what exactly is going to happen in that part. Then we'll see how 5G and 6G are going to support to realize the use cases, and towards the end we'll see what are the possible research directions, specifically being an academia guy and being from research fraternity. So we'll see what kind of research direction also. There are so many research directions are there, but I'll just point out a couple of research directions which I think researchers, academia, students, or even those things can be taken by the business guys. Those who are interested to start startup also can take it forward in that direction as well. So let us start with the internet, right? The whatever talk we are going to give today is through internet, right? Internet was sometime, it was some kind of in early 2000 or 98, 99, when I joined my first job in Siri Pilani. So there are five things were there. I remember five things were there to file income tax. One, if you have a car. Number two, if you have telephone. Number three, if you have credit card. Number four, you have visited abroad. Like this, there are five things are there. And if you have flat or something, right? So, like if you have a telephone, also it's a luxury item at that time. But now telephone is not at all a luxury item. Forget about internet, right? So internet is the bare necessity now. It was not a luxury item now. It was a luxury item in early 2000 or late 99 90s kind of things, but now it is a bare necessity thing, right? It's connecting people, it's connecting things. Okay, so that's what the internet is, right? It connecting everything, connecting people, things, devices, everything. And we are seeing unimaginable use cases, not only the academia or healthcare or retail. So many other use cases are there, like to monitor birds movement, to monitor wild animals movement. Okay, so if you have some RFID there, or if you place some chip there on their body, or some skin, or some on their horn, okay, or the feather, and try to see where exactly they're moving, try to monitor all the kind of things. So all the things are there, like, and all the things are happening because of internet. Internet is not only, if you see, only browsing. Internet is the combination of everything. It's all the protocols are there. Okay, all the TCP/IP protocols, 5 layer protocol, or you call me 7 layer protocols. All everything is there. The communication network is there. Then the devices are there. That's the entire internet, right? The digital, and it is like everything is becoming digital, like in the last couple of years. Like finance sector is also becoming digital. Now everybody is having Paytm, Google Pay, Phone Pay, so many things. Hardly anyone carry cash, right? Now carrying cash is also a problem these days. Like we don't know when it is going to be having some issue or something. So carrying cash also is a problem. So everything is becoming digital. Okay, in the present as well as the future itself. So, in short, internet is mother of all changes. Internet is there. That is because of that everything is changing. Right? In yearly summer vacation days, in my childhood days, we used to have evening time. We used to have some kind of get together, some kind of chit chatting, or some kind of drama, or some kind of things used to be there. Now, because of internet, everybody is having mobile phones. So everybody is busy in the social media. Okay, so life is moving towards social media. Life is moving towards a virtual world. Now the augmented reality, virtual reality are becoming real. Okay, so things are becoming virtual, things are becoming augmented reality, and all things becoming real. And the devices are becoming very very cheap, right? Into nearly 2002 2003, the like receiving a mobile call was like almost 15 rupees for just to receive the call. Now is all everything is free, right? Your applications are there, communication technology has evolved a lot, your devices are booming, right? Now digital avatars are there. Now it is like, as if I am sitting here, and one of my avatar can sit there in my office building, and talk to my colleagues, talk to my present in office meetings, and do what are the things I should do. Okay, at least regular things using ML AI, using the kind of artificial intelligence we have, we can do all kind of digital avatars. And the one person can be there in multiple places. Omnipresent kind of things can be realized in future. Okay, and all the things are happening because of cost. Okay, if it is a costly affair, nobody is going to buy. So you have to bring down the cost. How the cost can be reduced? Cost can be reduced if the more number of users. More number of users means there will have more demand will be there, right? That everybody will be putting effort there. Then you will have more number of applications, more number of devices. Then the unit cost price will come down, and ultimately everything will come down. Then, other than that, the wireless technology, whether you call 4G or 3G or 5G, or the old GSM technology, or even Wi-Fi 6, everything is there. Right? The wireless technology is changing the scene. So you can sit in the jungle, or in the temple, or in the sea beach, and can join calls, can attend meetings. And many of us in attending this call are might be sitting in their with a cup of tea or sofa, or somewhere else, attending all this talk because of the wireless technology. Wireless technology is not specific to any 4G or 5G something, right? It is there, not only cellular technology. It is there all kind of things, all kind of Wi-Fi can be also there. Your wired network, part of wired network can be there, but ultimate, the end, the your access network is wireless, I mean to say here. Because of the wireless technology, things have changed drastically. And somebody used to say, change is the only reality in this world, and change is the only certainty, certain things in life, right? So change is going to happen, and you have to accept it. We all have to accept it. Change is going to happen, right? And as I mentioned, keep like when the changes things are happening, changes are happening in the application world, in the device world, in the networking world, in the communication world. So you will be seeing so much of data. Like you have to understand ki, okay, who is that user, whether that user is buying medicines, what search he is doing, right? If you are doing some Google search, what search he is doing, that if he is searching some medicines, then should I show some applications related to that medicines? Should I show MedPlus? Should I show Apple or something else? What should I do? Right. So there are so many artificial intelligence are playing behind this scene. Okay, and today the data, whatever we are doing, is being processed in real time, in offline, and it is coming back to us, giving you what do you need. You might be interested in. Like if I go to Amazon site and look for something else, it will show okay, if I'm buying say a simple pen, it will show okay, like you may be interested in buying ink. If I want to buy say soap, it will say you may be interested in buying something else similar to that. So all kind of things are coming, right? So today data is becoming the new oil. It is the most costliest part today. Like if you have the data, you know what the customer is doing, what the user is interested in. Accordingly, you can fine tune your products, fine tune your applications, you can fine tune your customer care, and then you can talk to the guy and do whatever you want to do. So like somebody says data is the new oil today, it's the new revenue. If you have data, everything can be done, right? And it, because of data is available, you can have machine learning, you can have artificial intelligence. So it's the cycle is going on and on and on. And it is not only changing the world, it's disrupting every sector, it's disrupting the entire world, disrupting the physical world, disrupting the academic world, disrupting the research world, it's disrupting the business world, disrupting everywhere. Like chat gpt, the things have come now. Nobody is going to write, like because of the artificial intelligence, things are happening in Bollywood. Like those who used to write songs or lyricists, there is no need of lyricists now. I need this kind of masala song, or I need this kind of sad song, I need this kind of romantic song. Put to that AI module, and it will give a Hindi song or English song or Telugu song, simple, without any problem. Okay, so in 1 minute you will get the song. 1 minute you will get the entire movies, or short movie or full movies, entire script. So you would, all the authors, then lyricists, their job is gone now, right? You have to find out a new way of doing it. So it is going to disrupt the entire sector, in every sector. So in my opinion, when we see disruption is coming, that means there is some kind of opportunity is also there for all of us, like engineers, researchers, academians. You have more and more opportunity. Let us utilize those disruptions and convert the disruption into opportunities. Okay. So if you have to bring that disruption and opportunity, you have to understand what is the smart. Okay. Then which is disrupting? If something is disrupting, means that is smarter than us, right? The smartness, right? If the smartness is there, can I understand that smartness and try to see what opportunity is going to give? Like in the smart world, we have smart life, smart health, smart home, smart village, smart city, everything is smart. So if simple use case, smart home. If I have a smart home, I have all kind of devices are there, all are connected. Like my TV is connected to Wi-Fi, my fridge is connected to Wi-Fi, my geyser is connected to Wi-Fi, or everybody is connected. My CCTV is connected to Wi-Fi. So if I'm at office, while coming back home, I can tell, okay, switch on my geyser, make the temperature this, switch on the AC, and with this room temperature, all things can be done, right? So if you have to, so this brings some kind of opportunity in terms of you have to create new applications, you have to create new devices, you have to develop new devices. When you have all kind of smart things, then security, privacy also come into picture. They have to bring more and more security modules, you have to more cryptographic modules has to be there, more privacy things has to be there, then more regulations. Okay, then the police also has to understand better and better, because you don't know what is going to happen. Okay, and what is being recorded, what is not being recorded, what data is being sent. Okay, all the things happening inside home, whether they are sending to their site or not, all the things are going to be there, right? So more and more opportunity will be there, more and more job will be there. Okay, so if one job is gone, 10 new jobs will be coming. So we don't have to worry at all. We have to find out what are the opportunities we are going to see. And this brings complete change in the lifestyle. Today, almost 86-87% people have smartphones. Almost 6 billion people have smartphones, 6 point some 5 billion people have smartphones. And more than 50% people abandon a site if it takes more than 6 seconds. There is no patience at all. It should work means it should work in no time. 5 seconds, 6 seconds is not at all a big thing. If it is not working means it is not working. Leave it. That means you need to be always to the best. If there is nothing better, best means it will work. If you are the top one or two, then it work. Otherwise, it doesn't work at all today, right? And it brings a lot of opportunities. Like when you have 50 billion smart devices, and the smart devices are growing, you have to have the communication mechanism. You have to have new protocols requirement. You have to have new routing mechanism. You have to have new device to device communication mechanism. You have to have new IP addressing mechanism, whether IPv4 will work or IPv6 or any new other mechanism. Okay, or new addressing mechanism, whether this existing network or the TCP IP network is sufficient, or you go for content delivery network or information centric networking. So these new things are going to come, new opportunities are going to come, new challenges are going to come, because the devices are there. Devices are not going to be staying idle. They are going to generate data. How much data they are being generating? Almost 1.7 MB data is being created every second by every individual. Okay, so just imagine how much of data we are generating. Sitting just idle at home, you might be generating 1.7 MB data. Earlier days, internet downloading was interest. People used to download. Uploading was very minimal. Now uploading is enormous. Whatever you do, we go to some place and see some interesting things, make Facebook live, or do a WhatsApp call, or make a Facebook call, or do something live kind of thing, right? Or Insta live. So many things are there. Like things are getting uploaded today. The videos are getting uploaded, photos are getting uploaded, whether Facebook or Instagram or Twitter or so many things, right? And today almost 8 to 10 hours people spend in internet. Okay, and there is almost 60% of time increase in social media time. So people are more social in the social media. Okay, not in the real world. People sitting very close to each other, they don't know who are they, right? Or even in the family also, inside family, people might be talking to each other over social media. So that things are happening. Things are. I have to accept it. There is no other option other than accepting. While accepting, you have to see what are the challenges it brings, what are the opportunities it brings. So as I said, the smartness brings opportunities, and we have to work for those opportunities. When you see smartness, you have to devise one thing. I said, then the data one thing. Said, like everything is being digitized. Now, I'm taking a photo. That photo has to be digitized. Video I'm taking. That thing has to be digitized, right? See, or I'm doing a transaction, say, banking transaction, that is being digitized. When I do digitizations, whatever I do, whether sensing or taking photo, whatever, agriculture, any sector I go, or education, tourism, media industry, wherever I go, digitization is the key, right? If I go to hospital, my entire health record should be digitized. My ECG has to be there, it should be there, blood report should be there, everything should be there in proper format, so that doctor can see in no time and see my history, what has happened, what medicines I took, everything should be there. Like if I go to some, say, Konark, and I don't know, maybe for the first time I'm visiting, or maybe some other place I'm going, and I don't know about that place, I need not ask everyone. I simply take a device, and it will tell me wherever I go. It will tell you, okay, this is this thing, and this was built by this person on this particular date. All the things should be digitized. Entire information should be in hand, right? So that kind of thing should be there. You need to have personal devices, your sensors, your security. While doing all this digitization, security, privacy also will come into picture, and all kind of applications, whether agriculture, production industry, tourism, media, education, then healthcare, banking. everything, or citizen services like getting birth certificate or death certificate or inheritance certificate, everything. You have to have everything digitized. Then only there will be some kind of transparency, there will be some kind of authenticity, there will be some kind of the time, like guarantee should will be given. If you don't have that, you will not be giving at all. Like you don't know why is your file pending and why that is pending, and that person will be sitting simply on that part itself. So because of the digitizations, things are changing, and because of the digitizations, we are forced to develop new technologies. Let us see some more use cases in particular and try to see how these use cases are being realized today. We'll start with our own agriculture, smart agriculture. Today, like farmers, they know the soil record, they know soil history, what fertilizer will be given, okay, and what kind of seed they should be given, and if they seed that some barcode must be there. If from the seed, they'll come to know, okay, okay, from where exactly that seed has come, whether the seed has genetically modified or not. Every information will be there. Then what fertilizer will be given, and based on the weather report, which seed has to be given, whether they should do rice product or should do wheat or something or some kind of fruit or whatever things they want to do. Entire thing has to be properly managed. These days, everything is managed, and then finally selling the products. They know, okay, what is the price in which mandi, whether in Katak Chhatra Bazaar or Bhubaneswar Ek Number at wherever, everything has to be there. Like entire agriculture field, agriculture world is changing. Because of the innovations or inventions in the device world, in the internet world, in the communication world, things are changing. Your export, agriculture export can be sitting anywhere. Earlier days, people used to visit. My father was an agriculture officer. He used to visit every day, every village, every farmer used to talk. Now it is not required. Like your farmer can find it out, talk to the expert, the super expert sitting at home through their mobile phone and find out what disease their crop is having. Okay, all kind of things happening, and all the things is happening because of ICT, information and communication technology, your IT infrastructure, your sensors are deployed. They will tell you, okay, whether what water is required or not, whether any particular disease has come or not. They will be taking all kind of things. What is the humidity level, what is the water level, everything will be taken, right? And while doing all the things, so many devices, okay, you have to connect, you have to make it delay sensitive things, and amount of data you are sending, you need not send every data. You have to filter the data, you have to fine tune the data. So that means there is some new job is there, right? And you have to make it very, very energy efficiency. Those who are interested in doing a lot of research in energy efficiency, or doing some kind of uh, alternative energy work and research kind of things, very, very crucial work for them. Coming to smart education, like all of us are in education world, in the academia world, we know uh, how it is crucial during pandemic world. But the most important part is affordability. People in cities are, they can afford mobile phones, afford 4G, 5G, or whatever communications they have. But in village, it is not affordable. So you have to find out affordable way. So there is a lot of need to make it more affordable, 5G, 6G, more and more cheaper, right? And make it energy efficient. Because if, say because of say typical weather scenario, say in Odisha or in eastern part, or in west in Delhi also, even, and sometimes the power will not be there for a couple of hours, so 6 hours, 5 hours, 8 hours, 10 hours, there is no power. Today also there is no power here since 2 o'clock in the night, almost 10 hours, 8 hours is gone. So you have to make it energy efficiency. So that means with the less charge, you have to make how these things are going to sustain for longer period, and you have to make it virtualizations. So if you want to do biological experiment, you need not cut that frog, or you need not say those who are in first year MBBS student, they need not do everything, understand to all the human anatomy. They need not do all kind of dissections. They can see the entire part, body part, using 3D model or whatever, using haptic models. They can find it out, right? So then they can understand better and better. They can find understand things in a better way. before actually touching, because actually doing the experiments, actually cutting the bones or the skin or the like muscle or whatever things they want to do, right? So you have to have bring a tactile internet there, you have to bring haptics there, okay? And all the things is happening because of the internet, okay? Not only internet, your communications technology, your computing technology, so you are doing so much experimentations. So when you do experimentations, so the computation world, your server world, your the process world has to also do all the things and tell you whatever you want, it has to be processed, and you should get the response in no time, in real time, right? So your computing module, your communication module, your control module, all the three C modules should work in a very systematic manner and very uh, up to date manner. Then only things can grow, things can happen. Similarly, coming to robotics or UAV or drones kind of things, robots are becoming very, very normal these days, and they are part of life. In fact, in our area itself, this area itself, and particularly near to Kit, we have robots serving food. They are deployed in hotels. Robots are also deployed in hospitals. Most of the hospitals today have robots doing surgery. They're doing taking photo, doing all kind of cleaning job. All kind of things are happening. When they have to do all kind of things, they have to controlled, they have to be managed, they have to be maneuvered by somebody, by central stations, by somebody, because they will not be doing, you will not leave them as it is, right? So your similarly, if you go have to drones during say heavy rain or heavy wind or heavy say cyclone kind of things, like funny we had say disaster kind of things, or you have flood kind of scenario, how will you understand what's exactly happening, whether that area is completely submerged, with that anybody is stuck in the building, or during fire kind of thing, in somebody is stuck in the building. So you can send your UAV, you can send your drone to that particular area and take a capture a real-time video and communicate to that place, the central station, and see what exactly is happening. How then you can do how rescue teams you can send, you can do whatever things you have to do. So this requires a lot of communication mechanism, communication methodology. Patra sir is there. He has been teaching satellite communications or faculties are there. So many, whether you will be doing all kind of line of sight communications, you will be doing satellite communications, you will be doing terrestrial communications, or you will be doing microwave communications. What kind of communication mechanism you will do? What frequency you will be do? What kind of antenna will be doing? You will be utilizing? Whether the or whether the existing antenna will work, or you have to have very different kind of antenna, whether you will be using MIMO kind of mechanism, all kind of things. Like it's not only the flying device is very important, it is the device inside the flying device are also very, very important. And the background thing, the communication mechanism is also very, very important, right? So, and the entire infrastructure, creating the infrastructure, right, is also very, very important, right? We have robots in every field now. You have drones and UAVs at every field now. The connectivity, regulations, and you should not use drones to create havoc, create issues. So that is the reason there is need of regulations, need of standardizations. Where to put drones, what not to put drones. All kind of things will be there going forward. Okay, so because of communication technology, because of computing technology, things have also grown up. Another important thing is tactile applications. See, earlier days, like delay, those who are doing research or understand quality of services, simply if you make a call, say international call, in most of the international voice calls, you used to have echo kind of thing. Echo is because of the delay, or it will be like delay kind of, like you say hello, you'll be getting some response after some time. That delay was almost say couple of seconds, or sometimes less than 1 second kind of things. So those kind of delay used to be there. Now our ear can understand if it's 100 millisecond delay or more than 100 millisecond delay, it can understand that there is a echo or there is a delay happening there. But if it is less than 100 millisecond, it will not understand, it will say okay, very, very real time kind of thing. Similarly, I can understand almost 10 millisecond. Okay, if it is less than 10 millisecond, it will not understand, it will say okay, real time, it is happening, the as if it is becoming real. But touch, sense, it needs 1 millisecond delay. So that means if I am doing something, Okay, if I'm say I'm doing some experiment, okay, say chemistry experiment I'm doing or biological experiment I'm doing. Okay, so if I'm doing something in my robot at or my computer at home and I'm getting a response in 1 millisecond, that means I will not feel anything is happening in that side. I will feel as if everything is happening within the virtual world, in the augmented reality world, in the real world now itself. Otherwise, I will not understand. I will see there is some delay and I will not feel exactly is happening. Similarly, if say you are having a music orchestra in kit, okay, but the singers are they have not come. Maybe one singer is there in Sambalpur, one guy is there maybe in Barampur, one guy is in Bhubaneswar, and tabla guy is somewhere else, maybe the bhaolist is in some other place. Um, you can have many people at different places, but if you use the tactile world, if you use the haptic world, then you can bring all together, like with the delay of 1 millisecond. You can see as if everything is played real time in front of you. Okay, so that's what the tactile applications, that's what the robotic arms are going to do, that's what the haptic world is going to do. Okay. And another example I will give you is the robotic surgery. Like we have a lot of heart attacks, a lot of like say sudden deaths are happening. So, or if you want to have say some kind of heart surgery or bypass surgery, and doctor may be somewhere in say in Cuttack and the patient is here in Bhubaneswar. If doctor has to come to Bhubaneswar do the surgery, it may take almost 30 minutes, and by that time patient will die. Can the doctor sitting in nearby hospital in Cuttack do the surgery here itself? It is possible if we have robotic surgery, robotic communications, tactile communication is available. That means doctor can sit in SCB Medical College Cuttack, patient can be there in AIMS Bhubaneswar or in KIMS Bhubaneswar, and all the things are this entire surgery is going to happen in KIMS, and the doctor can be there in Cuttack itself. He can do the surgery sitting itself as if really he is doing the maneuvering all these instruments, cutting, cleaning, sucking the blood, all kind of things, or taking the camera, making zoom particular area, all things he can do itself. And that is possible if the entire end-to-end delay is less than 1 millisecond, right? And less than 1 millisecond means you need to have huge amount of data communicated in no time, right? Because so many instruments are there. You have light, camera, you have seizures, you have so much video, so much other things are there. Your ECG data, all data, all your health data is available in front of the doctor in SCB, right? That means so much data is being communicated to the doctor sitting at the other place, right? So you have to have communicate so much data. When we communicate so much data means your communication mechanism methodology should be very very fast, right? So that's what the tactile world. Not only this one, you have to have create a some kind of sensing mechanism. Okay, that's the haptic world. You have to create the haptic sensors, so you should feel, right, as if I'm doing operations. I should feel that heat, I should feel, I should if I don't feel the patient, if I don't so while doing surgery, if I don't feel the pulse rate, then I'll see I'll feel something different, right? So I have to have that feeling. That feeling means, that means the whatever the pulse rate is there in with the patient, that has to be translated, that has to be coded, decoded, and that has to be given back to me, to the device where I virtually doing all the things as if, and then only I can see what's happening, right? So that kind of thing is required with the haptic world. So you need to do a lot of research in the haptic world itself, right? So the communication and sensing is very very essential, and this requires a lot of regulations, a lot of standardizations, because if the standardization is not there, anybody can bring anything and they can completely rule the world, right? But if your standardization is there, it will give you open things to everybody, right? You can create a new applications, new device, new things, or new communication methodology, and it can contribute to the world, and it will not be manipulated, it will not be controlled by a set of people. Okay, so you need to have that kind of healthcare is going to come tomorrow. Similarly, this is the exact thing what I was explaining in the previous slide. So you do all these things sitting at the SCB Medical College and doing the surgery in KIMS. Okay, the entire return time will be almost 1 millisecond round trip time kind of things. Then only you will see what exactly is happening, that kind of things, right? So going back to some news topics like say healthcare per say senior citizens during COVID time, they were the most vulnerable people, right? So it can happen, COVID can happen anyone anytime, right? If anybody visit to them and they can transmit, they can get that whatever disease, and that can create more problem. So if they are safe, let them be safe. But then how will you communicate with them? So we need, and what if they are getting some medicines, if the vital data has to be given to us. So because of, if you have this kind of 5G communications, if you have 6G communications, if you have this entire communication mechanisms there, then we can do because patient data we can collect at that in their place, and that can be communicated, and doctors sitting at home or sitting in the COVID hospitals can do things. Similarly, robot can go in the COVID hospitals, take all these measurements, meet the people, do the tests, and come back. So you very less exposure, human exposure will be almost negligible. Similarly, exoskeletons. Many people today are having this kind of some bone problem or some muscle problem or some not problem. So using exoskeletons, you can give support to that particular persons. And like some people who are having polio, they are unable to stand, right? But if you have exoskeletons kind of things, they can stand, they can work, they can do all the kind of job. So that can give new life to new people. So this is possible if you have communication mechanism. This is possible if you have 5G, 6G is there, right? So other applications like you have AR, VR applications with haptics. You have the robotic world. Um, you have all these robotic operations like specific hazardous environment, like if some chemical warfare is there or some kind of say uh, some poisonous gas as emitting in some particular place or something happened in particular place, and difficult to send people to that particular place. Can I send UAV or robot to do the job, treat the people, bring back or give some medicines, give some masks to them. So that kind of thing can be there. Like all the things possible because of AR VR operations, and because of all kind of haptic or tactile kind of things today. Other applications today, we have smart traffic management. You can sit anywhere. Like say daily traffic is very tough. Traffic management is very tough. That's the reason they have even someday odd kind of vehicle management. Similarly, Bhubaneswar is not that far off, apart from that particular traffic chaos. It can happen in Bhubaneswar also. So if you have traffic management, and then and all the traffic data can be given to Google Apps or similar kind of apps, then we can see, okay, from this place to that place, we can find out the exact time, and you can find alternative paths in very real life scenario. Similarly, rescue operations, gaming also, online gaming also, like many your friend can be there in US and other friend can be in Japan. You can sit here and play all kind of things. You can do all kind of real life gaming, online gaming kind of things that can happen. And the driverless car also is realizable if you have this kind of communication, this kind of things. Because driverless car needs vehicle to vehicle kind of communications, vehicle to device kind of communications, B2B or B2X kind of communications, and then only it's possible. Then only collision can be detected in winter time in northern India, like because of the thick fog, almost 1 meter away, you cannot see what's happening, right? So if you have this kind of communications, then you can understand using that scenario is almost driverless kind of scenario. So using sensing mechanism, using your haptic communication mechanism, you can understand, you can put the brake, okay, and see how to move, how to go in that directions without any accidents, without any life threatening kind of things, right? So these are some of the use cases which are going to rule the entire world. Okay, we are seeing revolutions in everywhere, as I mentioned. We have like smart devices explosions are there, super fast hyper connections are there. cost-effective systems are there, giga service demands are there, then welfare infra, the banking, citizen services, so many things are there, right? So industrial revolutions or the user-specific things are integral part of the change in the society. Okay. So just to summarize, there are so many use cases today. We have smart office, warehouse, transportations. You have 3G video, you have tactile internet, you have education, healthcare, cloud computing, safety, smart factories, smart village. Everything is there. So many next generation use cases are happening today, and these are giving more life to us, more opportunity to us to survive, to create more jobs, and to get more and more revenue out of it. Right now, let us see how to realize these kind of services, this kind of application, this kind of use cases. So if I have to realize from a business perspective, I need to, from business perspective, I need to understand how I'm going to understand the user focus, how am I going to bridge the user focus, how the business focus and the user focus are getting bringing together. If I have to bring together, then only I can create new use cases. Then I can create new services, new applications, right? Then I can release some new applications like healthcare, new applications I can release, or I can create a new TV or new mobile services, new app kind of things. So from business perspective, I need to have agile, I need to have non-linear growth, I need to have agnostic. Agnostic means today I'm having Cisco devices, tomorrow I'm going to go Juniper devices, or Dell devices, or maybe Airtel, or maybe from communication perspective, maybe BSNL or Geo. It is agnostic. My entire protocol should be agnostic. My devices should be agnostic. My network should be agnostic. I should not depend upon particular guy. If I depend upon a particular guy, then it may impact my business. Okay, so I need to bring more and more user experience, right? And this brings, from a user perspective, user wants cost, very very limited cost. Speed should be enormous speed. Security should be there. Intelligence should be there. Okay, and they should get all kind of next generations networks, very very fast kind of things. Now, from the business to technology, user part I understood. Business has to understand the user part, and business has to realize the user requirement through the networking, through the technology. What technology we have today? We have 5G and 6G. Okay, we have accelerated age, we have AI, then we have zero trust security, we have multi-cloud network, we have ML, we have so many other things, and these things can be you taken care. These things can be utilized to bring more in user enhanced experience. You can bring mobility, you can bring confidentiality, you can make big resilient operations, you can bring automations, analytics, all kind of things. So business can grow, business can sustain, business can further and further transform, right? So user things can be uh, transport. User things can be translated to actually realize the realizations through the technology use cases. Now this requires hyper connectivity. That means earlier days only I'm connecting, one guy was connecting to one to one or many to one kind of thing. Now everybody is connecting everywhere, right? So you need to, when you bring everybody to everybody, that's become hyper connectivity. When hyper connectivity is there, and from a business perspective, or from the research perspective, if you have to create something, suppose I propose a new protocol, okay, new routing protocol. I cannot say a new, that I cannot say in all the existing routing protocols will be thrown out. No. Suppose 6G plus some new things or cellular technology I propose. Okay, that means, that doesn't mean that all this existing network technology will simply be thrown out, because people will not, in India people will not throw out their mobile phones. Even if 4G, 5G, 6G, they still be using their old phones. So coexistence is the major thing. You have to understand, whatever thing, whatever business you bring, they should coexist with the existing thing. Okay, the existing thing cannot be completely thrown out. You bring new things, but coexist with the existing thing. When you bring coexistence, you have to bring smart connectivity, you have to bring intelligence, you have to bring security, and that brings multi OEM landscape, that brings application aware networks. So when you bring intelligence, that means you have to understand the applications, you have to understand the applications requirement. Some applications, like say if I'm doing a banking transactions, If I'm not sending or not getting the information in say 10 millisecond or 100 millisecond, then it will give a error, right? But if I'm doing a YouTube kind of thing, 100 millisecond, 200 millisecond delay is not a big problem, right? So that intelligence is required from application perspective. So application aware network design has to be there. So if I'm going to design the network, 5G network or 6G network, if I'm going to do slicing, so I need to understand what is the application requirement. Okay, so you have to have, then if you bring the changes, where exactly are going to bring the changes? You have to bring the changes in the cloud, you have to bring changes in campus network, bring changes in the branch network, data center network, applications. Then you have to bring those things in sites, plants, labs, stores, facilities, everywhere, right? And bring new domains, your education, manufacturing, retail, utility, agriculture, energy, education, everywhere, banking, finance, everywhere it will be completely changing, right? So let us see how these use cases are being translated through our applications or through our technology itself. Now, coming from the technology perspective, new thinking is always green. Whatever I do is green. Okay, that means less energy. Virtual, virtual में हो जाएगा क्या? It can. That means question is, without going, can I do something? Can I, like, if I'm not going means I'm consuming less petrol, I'm consuming less energy, I'm sitting at place. Okay, I'm putting less traffic in the actual road also, right? And speed, it should happen very fast. I should not go to hospital, go to all the things. If bare necessity things are going, they know, like, I should go. So in this brings a rethinking of applications, rethinking of services, rethinking of capacity and control, right? That means whatever capacity, earlier I used to have 1 Mbps link at my home. Now I'm having 100 Mbps link. That is also not sufficient. And control. Now I should have control key, 10 devices there. Which device should do what? Whether they should be able to use watch YouTube, like, is very much essential in academic institutes. Whether hostel guys should watch YouTube in daytime, evening time, all other time. What they should do, all kind of things. Rethinking of capacity, rethinking of control, the rethinking of platform. You bring new platform, whether these old devices, desktops is sufficient, or new desktops, a new thin client will be sufficient. Rethinking of environment, rethinking of profit. Nothing will work if profit is not there, because nobody is going to do in free, because you have to survive, right? You have to survive means something has to be coming. So some return has to be, return on investment has to be there. Then only things will grow, things will evolve. And rethinking of services, in which areas? Manufacturing, energy, healthcare, retail, banking. In manufacturing, simple example, you have industrial process and production automations. Can I do automation of the entire process? In energy sector, can I do sustainability? In healthcare, can I do 360-degree healthcare? Can I retail? Can I connect all the devices, warehouses, stores, right? So that kind of things. Now, when I'm going to realize these things, I have to have immersive applications, tactile applications, ultra reliable. Reliability is very, very important. And these things to be connected with seamless and ultra dense and massive. So many devices, 50 billion devices, right? Cricket match or say a hockey match, thousands of people will be there, ultra dense. Everybody is going to send a real life video, real time video, and that video should go, right? So they have to have the communication mechanism should be huge, the capacity should be huge, right? And seamless. Like when I'm traveling, it should be seamless. My flight should travel seamless way, my car should travel seamless way. If driverless car is there, it should be, or driver assisted driving methodology, that is also seamless. Everything should be there seamless. If I'm using Google Map while driving, that should be seamless. I should be getting real life feed, right? And all whatever information I'm going to get, it should be reliable. It should be ultra reliable. Okay, it should not be very old information. It should not be like, say, road is closed say 10 days back, but still I'm seeing today's information. It should not be there. It should be ultra reliable. Okay, it should be giving authenticated data. And while doing all the things, from the research perspective, from the engineer perspective, bring agility, bring efficiency, bring innovations. Then only our tomorrow can grow, then things can happen. Now, how to realize? as I said, like realization can happen because of guaranteed communication with mobility support. Right? While I'm driving, I should watch my Google Maps, or if I'm on call, I should be able to attend the calls. So guaranteed communication with mobility support. Dynamic link coverage and congestion predictions. Right? Whether congestion prediction in the road traffic or the network traffic, all kind of dynamic network provisioning. If 5G is there, fine. If 5G is gone or congestion is there, simply you should move to Wi-Fi. Or Wi-Fi is congested, move to Wi-Fi 6. It should be dynamic provisioning, real-time dynamic provisioning. And applications has to be redesigned. Some applications may not work. They have to redesign, right? And you have to give a huge amount of data, right? 360-degree stereo cameras will be there. And the packet error rate 10 to the power minus 6 to 10 to the power minus 10. Today 10 to the power minus 6 minus 7 will be are there in specifically for 5G kind of thing. But if you go for 6G kind of thing, 10 to the power minus 8 minus 10 kind of things. So that kind of error guarantee should be there, right? And reliability 99.99999 four nines. That means in simple case, if you simple 99% reliability means in a year there will be a possibility that 3 days failure will be there. Can I afford in healthcare industry 3 days failure? No. People, lakhs of people will die. Even 30-second failure in 99.999 is also too much in a year. So I have to bring down the 30-second to in 1 second. Okay, because some people will have some use cases will have that kind of reliability. So extremely high reliability, extremely high availability has to be there. I cannot afford, especially hospital industry, especially retail industry, especially the transport industry. Okay, so that kind of thing happen. So extremely low mobility, 10 to the 1 to 10 millisecond kind of things, right? Nanosecond kind of things. Scalable, vendor independent solutions. Okay, and bringing that to the actual world, you have to bring drones, you have to bring robots, you have to bring augmented reality, you have to bring virtual reality, you have to bring machine learning, artificial intelligence, cloud, emulation, smart manufacturing, cyber security, IoT, integrated systems. So many things will be there. Okay, all things will be connected. Now, how to achieve these all the things? You have to create new platforms. You have to create new system design. You have to create new hardware, new software. Communication perspective, bring 5G, you bring 6G. We'll see why 5G, why 6G, and bring automations, bring machine learning, bring artificial intelligence, and bring more interactions, control, seamless. Okay, that kind of control has to be there. Your control, your communications, your compute is part of platform and automations, communications and interactions is a part of the control itself. All the three C, control, compute and communications, right? We'll have more focus in the communication aspect. Okay, a communication aspect is more or less in 5G or 6G, whatever 6G, well, is evolving in the wireless sectors. Okay, we have so many smartphones, so many applications are there. Okay, and let us see how 5G, 6G are really going to evolve and going to help us in realizing these things. If I have to have V2X kind of thing, or you have to have bullet trains, okay, then I'm going to travel at say 350 kilometer or 300 kilometer in at least in lower case. If you have to support 350 kilometer per hour, then 5G can support. More than that, I have to go for 6G. 6G can provide 1,000 kilometer per hour kind of things. Okay, super bullet train like in Japan, 5G is not sufficient. 6G has to be there. But if I have to have this driverless car, or if I have to have bullet train kind of things, I need to have huge amount of data to be communicated. So I need to have 10 gigabits per second data transmissions. Okay, it's almost 100 times faster. But if I have to go for 6G, I may, if I have to have say, if I have to say internet in aeroplanes, right? Internet in flight, I need to have huge amount of data communications, terabytes of data communication. Then I may go for 6G kind of things. Latency, what kind of applications I am seeing? Okay, cloud to cloudlet to AS kind of things. 1 millisecond support to air to tactile internet. The 5G can support all kind of smart X. The density 10 to the power 5 6 like kind of devices per kilometer square. Okay, so many devices per square kilometer. So then 5G can support. Cost, your IoT support, all the things can be supported by 5G. 5G has three kind of traffic management or three kind of traffics: EMMB, MMTC, or EVRLC. EMMB means extreme mobile broadband. Then MMTC is massive mobile massive scale communications or massive mobile communications kind of things. The URLC is ultra reliable, low latency communications. If you have EMMB kind of things, today or more or less EMMB kind of services are being realized. Your human to human, virtual reality, augmented reality, your fixed wireless or your video calling, virtual meetings, part of my human to machine, your fixed wireless will be there. Machine to machine, your video monitoring, your mobile to cloud computing, part of my EMMB kind of things, part of my machine to machine communications. Okay, this comes under 5G. So if you have 5G communications and if you have applications, say virtual reality applications, augmented reality applications, then that falls under EMMB. That means if I'm having 5G communications, I have to create a slice for say virtual reality. That means I have to give priority to EMMB traffic. I have to create a slice for the EMMB traffic, and then if it is user priority is there or the application priority is there, then I have to choose what priority or I have to calculate the total priority, and based on the priority I have to create a slice, create a virtual network, virtual end-to-end network between the user and the server or the application or between the user kind of thing. Similarly, if you have MMTC, massive machine type communications, massive machine time communications, or more or less variable social networking, healthcare monitoring, okay, all the things are coming to massive communications. There, your delay requirement might be little less. Okay, your QoS requirement might be less, but the data communication, huge of data will be communicated because so many sensors will be there, so many tracking devices will be there, massive machine type. Now, so many devices will be there. You will be sending so much of data at that time. Now, if you go for ultra reliable low latency, that means reliability is here 99.99, and you have to have very low latency. Very low latency means you have to have a dedicated hotline communications. That means if you are creating slice, then create a slice with 100%. That means even if they are not using, it should be there, and there should be alternative. This slice, if something goes wrong, there should be multiple other options should be there, whether from 5G say cellular network to wi-fi 6 to cellular, or even some part of the data can go in using multipath TCP, some part of the data can go in cellular, some part of the network data can go in the wi-fi 6 or wi-fi 5 kind of things. All the things should happen, then only it is possible. Similarly, your remote surgery, vehicle to pedestrian, vehicle to vehicle kind of communications, all are part of my ultra reliable kind of communications. So 5G, those who are interested in 5G, uh, research, lot of work is happening in low latency communications, in how to create the entire end-to-end setup. Okay, how to create more slices, how to create the virtualizations, because when you have to end-to-end means it's not only the core network or the access network. Okay, it is the entire access core, the other side access, and the devices also, because 5G brings virtualization means your server has to be virtualized, your virtual machines will be there, right? You will be getting a virtual path. When you have a virtual path, entire virtual path will be having so many virtual machines, because your applications will be there in some virtual machines in some cloud, right? So entire end-to-end communication has to be there. The entire architecture design is also very very essential, and that brings a lot of research opportunities. How 5G can enable, as I said, virtualizations of applications, services, networks. Virtualizations, when I talk about virtualizations, I need to understand the network aware applications. Okay, applications should know how the network is. Like simple example I give, those who are watching IPL, okay, if the network is slow, then you should be getting, maybe your application should bring back to lower quality. If the network is good or the speed is good or you having the signal character is quality is good, you should be getting HD quality of video. Okay, so that is the network aware application. So applications should learn from the network characteristics in real time and code, decode, and also accordingly. Similarly, your network should be application aware. Like if I'm going to use SD applications, then my operator should give me more and more network. That means it should give more and more bandwidth, more and more so throughput to me. If I'm going to use a simple browsing, then maybe it will not give me that kind of bandwidth. It will give that bandwidth to someone else, because there is a resource crunch, there is a resource constraints, right? So the application aware and network aware are very, very essential. A lot of research is happening in that directions. In fact, we have done couple of papers there, and couple of patents are also there. And this brings heterogeneity. Similarly, network orchestrations, dynamic network orchestrations, that brings your network slicing, your end-to-end slicing, your seamless integration of networks, your guaranteed mobility. If you are having, say, if you are sitting in Mobos and moving from, say, Kims to Orchid to, say, airport, you'll be moving so many places in the on your way, right? Moving, all the hops will be there. So you are watching some movie or something, you are doing something, right? So while moving, or while traveling, so you will be connecting, say, via the access point or the via base stations at Kit, then via maybe at TCS office, then Infosys, then somewhere else. Like this, it will be connected, right? So you will be getting end-to-end slices. Like your endpoint is are moving from one base station to other base stations, other base station to other base stations, moving one by one kind of things. So it should guaranteed mobility should be there. So I cannot have a fixed end-to-end slicing. The slicing also is going to dynamic, and that has to be seamless integration should be there. Now IT OT integration, the IT world and the existing OT world, they has to combine together. There has to be one world. Like the hospital network, there are so many devices are there. IT work, so many devices are there. They don't talk to each other. Doctor's mobile phone doesn't talk to the whatever, say, smart devices there at hospitals. But if they can talk to each other, then doctor sitting anywhere can see your with proper authentication, see your health records, and can monitor, can treat you appropriately. Similarly, you have to bring a new physical layer. Your existing physical layer is not sufficient because you have reached to the channel limit. You have already reached the channel limit, so you will not be able to justify, you will not be able to create more and more applications. You have to bring more applications, so you have to create a new physical layer. You have to have new channel modeling. So channel modeling were there, not there for 6 gigahertz, not there for 30 gigahertz, not there for 60 gigahertz kind of thing. So you have to have different kind of channel modeling. Okay, new kind of pathless modeling. A lot of research is happening in that directions also. Then the couple of things 5G is talking today is new radio. There you have all MIMO arrows, beamforming, enhanced mark. Okay, then FR2. So many things are there, kind of things. Then see service-based score. Your see entire 5G or 6G. If you say they are, the philosophy is SDNizations. That means your control plane and the user plane is divided. Okay, your brain is moving out from your user things. So control plane is going out. So earlier days, one base station was having one control mechanism. Now multiple small base stations, dumb E node Bs or G node Bs will be there, can be managed by the control plane sitting in the cloud, right? So you need to have your service based score, and you need to entire deployment should be microservice based deployment, and it should be cloud deployable kind of things. Like your control can be there in the cloud, okay, and it should microservices means, so today particular application is there, tomorrow some new applications, just add another service, another microservice. Okay, so if your microservice kind of deployment is there, then it has become very, very easy. New applications can be there, new use cases can be there, new deployment can be there, new ways of doing can be there. The network slicing, as I mentioned, where you go, it should follow. Mobility should be there, right? MEC, telco integrated edge, if private 5G deployment. Okay, it's not that only telco world, it's not only the infrastructure, other world, the private 5G, the enterprise world, the manufacturing world, the uh, say particular sector, say retail world, okay, or the big bazaar or Amazon or those people, that world has to be properly managed with 5G kind of, or the airports also. So many buses will be there, so many AGVs will be there, so many flights are coming down, and so many people are moving. Okay, and if 5G or 6G kind of communication is there, then managing everybody becomes very easy. Otherwise, if you don't have all these communications, proper communications there, then the possibility that accidents will be there, possibility that threats will be there, possibility that some kind of security threats can happen. So all kind of things happen. But if you have 5G, 6G kind of things, it using machine learning, artificial intelligence, you can find out what exactly is happening, where it is happening, what can be done, who can move in which directions. And it can be the not only the speed in the communication world, speed can also be seen in the physical world. We can save a lot of time, lot of resources can be saved. Then everything can be software centric, right? You can have all kind of virtualizations over and all kind of things, and ultimately your artificial intelligence in every layer. Now going from 5G, 5G is not sufficient. As I mentioned, 350 kilometer per hour is not sufficient. I have to go 600,000 kilometer per hour, right? So there I need terabytes of data. The reliability 99.99 is not sufficient. I have to go 49 or 69 kind of things. Energy efficiency is not sufficient. I have to go beyond that. 1 millisecond latency is not sufficient. I have to go zero point 0.1 millisecond kind of latency. Okay, 10 to the power 6, then like devices per square kilometer is not sufficient. I have to have thousands of more devices will be added. So that comes from the 6G world. 6G world is actually the combinations is of the all the three world: the physical world, your digital world, or the human world or the biological world. All the three things are being combined together. Your physical world and your digital world, and your biological world or human world are being connected to that. Here you bring all ubiquitous computing, you bring all kind of precision sensing, actuations, communications, human to machine interfacing, knowledge systems. Entire brain is there, right? And that brain should be super fast computers, like supercomputers will be like theirs, like all these devices will be almost supercomputers kind of things, because then only you can process, then only you can manage so many devices, so many applications, so many uh, activities, so many communications, so many commands at a time. So you need to have 6G to do that. So if I compare from 5G, 6G, 5G gives 10 gigabits per second, whereas 6G give me almost 1 terabytes kind of things. Delay from 10 millisecond one to less than 1 millisecond. 500 kilometer maximum support 5G can support, can go for 1,000 kilometer per hour. Okay. But similarly, the energy efficiency, then downlink speed, spectral efficiency. Today it is 30 beats per second per hertz. It can go to 100 beats per second per hertz. That means you need to have different physical layer mechanism, completely new antenna mechanism. New those who are doing research in antenna, Professor Sudhakar Sahu is there. All the people can do have lot of research there in antenna kind of things. Okay. Then coverage things, earlier only cellular or Wi-Fi kind of things, all kind of things. Now cellular is where aerospace to ground, ocean integrated network, everything is connected. Frequency band, sub 6 gigahertz kind of things. Now millimeter wave, you have even 300 gigahertz band also is possible. Reliability is also high reliability. So all the things are going to be there. So applications can be realized through 6G. All these vertical applications, whether healthcare, educations, or even your say other applications like banking, finance applications. Okay, so agriculture may not be needing that kind of 6G, but my smart city so many smart city applications are there. They may need all kind of very reliable, very high speed communications kind of things that can be realized through my 6G. Okay, all cloud will be there. Your cloud was there earlier in the that means all your applications are in cloud. Now the applications are moving towards the edge now, the cloudlet or the fog computing or the edge computing. So that means your brain, it was there in the actually it was there earlier device, it has moved to cloud. Now again from cloud it is coming back to edge, it is coming back to phase, it is fog computing, it is coming back to cloudlet kind of things. You need to have distributed clouds. So it's not there only in one particular cloud, it can be there in multiple clouds. Maybe one business applications there in say Amazon cloud, other one maybe is in TCS cloud, other can be there in Microsoft cloud. They can be talking to each other. in a very seamless manner and do all the processing, all these communications in a very seamless manner. All the things should be possible. And you should have cell-free communications. You have ultra massive MIMO kind of communications. You have to have huge amount of IoT devices, V2X kind of communications, and wherever possible D2D kind of communications inside airport or inside say building or inside cricket stadium. You are talking to somebody else. Why to to the base station and come back? Can you talk to each other? Or inside the say mine kind of thing, can you talk to each other using device to device communications? Okay, so so many new protocols, new technologies can be brought by 5G and 6G today. And this also needs a lot of resource allocations mechanism, specifically from smart city or from the cellular network perspective. And this requires a lot of unlicensed spectrum utilizations. Okay, so unlicensed spectrum is very very essential. Like you have 5 gigahertz band or 2.4 gigahertz band, that is unlicensed band, and it's being Wi-Fi and other devices are being used today. 5G also using those kind of things. Okay, um, in using these unlicensed spectrum and trying to utilize the unlicensed spectrum for 5G kind of communications, for specifically LTU or LTE unlicensed kind of communications. That is happening, and that can be translated to 6G also. So that is also possible happening today. A lot of research is going in that directions, using because when you have unlicensed band available for these licensed communications technology like LTU, all kind of things that can impact my Wi-Fi, that can impact my existing other communications methodology available. Okay, so how to manage the existing network without getting impacted by the LTE, or impact by the 5G or 6G kind of communications. How are getting There's a lot of research is happening in that directions. You can file more patent, you can create more solutions, more applications, more devices, because you have to find out what is the best channel in Wi-Fi. You have to find out what is the best channel in that kind of scenario. Okay, and similarly, when multiple operators are there, can the operator talk to each other? Because if say operator one and operator two, operator three operators are there, maybe operator one has more number of users, operator three doesn't have more number of users. But they have spectrum. Can the spectrum be utilized by operator one or operator two, or whenever operator three wants, can they take it back? That kind of communication, that kind of methodology should be there, and then only you can have more and more saving, more and more return on investment can be there, right? And if you ask me from the 6C perspective, there are a lot of differencing factors. You have immersive XR, you have all AR, VR, or you have MR kind of things. Then optical wireless, your Li-Fi kind of communications. Your lights in the road, or the tube lights will be actually internet, the base stations for internet communications, right? That can happen. Your hologram, okay, real life expressions can be there. Using hologram, your 2D 3D can be realized, and that brings a huge amount of data communications. The data generation will be almost certain huge amount of data and things will be there. Then you bring generative AI, as I mentioned in the beginning. Like today, all the lyricist job or the script writer job is gone. So you bring generative AI. Generative AI will tell me, based on say your old record, health record, it can tell you whether you'll be getting cancer after 40 or 50 or 60. Then whether that gene is sufficient or something else has to be there, or SWAT injection has to be there. Using generative AI, all things can happen. So it is going to disrupt the entire world. And again, from the disruption, you have to learn something. You have to create some new solutions. Similarly, digital twins. You need not go there and do all kind of experimentations. Your digital twin can be there and do all the experimentations, or do all the work, and you can learn from that and fine tune your actual device or your applications. So many application service areas like B2B kind of communications, optical wireless, as I mentioned, holographic communications, as I mentioned, okay, cloud integrations, smart home, or then ocean, ground, air, space network integrations. That means entire world will be connected in one set, right? And this is possible only if I have software defined communications in 5G and 6G. You have infrastructure layer, you have control layer, you have application layer. That's what the CUCP, control plane and user plane participations. So you bring applications. That means you can create new applications. Anybody can create new app. Anybody can create new app control logic. Whether you use ORAN or you use SDRAN or you use something else, you utilize whatever things possible. That's a part of my controller architecture. And you can have infrastructure, any Cisco, Juniper, HP, Aruba, whatever, or even you can be a new vendor. You can put your new device and give it to them, and it's a plug and play kind of things. So entire 5G 6G can work if we have this kind of division in the entire setup. There is no binding that this should happen, this should do like this. And this brings new aspects for us, like from the CC perspective. We have more social impact, technical impact, economic impact, new network requirements, technology, research challenges will be there, services, so many things will be there from the 6G perspective. Now, coming towards the end, let us see a couple of areas where research is happening today, or research can happen. Are people, those who are interested, research scholars, faculties, PhD scholars can see in that directions. Smart health and city, smart city kind of thing. Assistant living, elderly people, differently abled guys, real-time algorithm analysis of clinical data, virtual reality using health checkup, intelligent traffic video analytics, real-time crowd monitoring, real-time threat detections, smart and integrated transportations. There's so many research directions is there. Okay, a couple of areas we are working, couple of areas like other our colleagues are also working, and they are open to all of us. To the challenges I brought today, the disruption I brought today, bring these kind of opportunities to all of us. Similarly, perhaps those who are in media, those who are interested in computer vision, audio kind of things, so video surveillance, edge computing, image classifications, predictions. Okay, then video services, business, advertising analytics, because YouTube gives a lot of money from advertising, right? So you need to understand key advertising analytics. Then only you can have better advertising mechanism. The Google is utilizing significantly there itself. There all this money there itself to understand how the people's behavior, what video they are browsing, what video they are watching, and accordingly what advertise should come, and how should they get more and more money. Okay, similar manufacturing industry also, you have autonomous vehicles, integrated guided vehicles, digital twins, remote operations, drones, machine vision inspections, augmented worker using machine vision, AR, VR, real-time remote loading, unloading at sites, fault detections in machines, products. So many areas are there where research can also happen today. Similar media entertainment, you have music concerts, live events using tactile, using haptic productions, delivery, virtual interface, then location 5G driven location based virtual reality. Okay, to summarize, to see what we have seen today, like so many use cases are evolving. All the use cases are being realized because of applications, devices. Okay, and they have the requirement, and these requirements can be managed by three C's: control, compute, and communications. Okay, and we are seeing use cases for today, tomorrow. Okay, and from the control computing perspective, specifically from the connecting perspective, 5G, 6G, your hyper connectivity is very, very essential. Other technologies which are going to rule, which are going to create more disruption today, tomorrow also AI, ML, generative AI, blockchain. Okay, and all the things brings a lot of new areas in governance, digitization, government services, rescue operations, your security, your regulations, your privacy, governance also is going to create a more role, right, in tomorrow. That's all from my side. Thank you. Thank you very much.